Hello, I'm Eric Snodgrass, and thank you for watching this in-depth ag forecast for Australia. First of all, I'm about a day earlier than I normally am. I'm going to be on travel for work today and tomorrow, and I'm a bit concerned about if I'll be able to get around and get home. We're having a bit of a problem with our airlines here across the United States, and so it's going to be a bit tricky. So I just wanted to get this content out just to make sure that we kind of stay close to our schedule. So this is what we have to talk about. Weather forecast models for the last 2 weeks did not perform well. All right, so if you have a look at this map, looking at the month-to-date precipitation in terms of anomalous precipitation, wetter or drier than average, we saw better forecasts for precipitation across much of the east. Now, we knew we were running the risk of being drier in New South Wales, but the models over-predicted a lot of rainfall in this area. And so every time we see this happen, we have to just investigate as to where did we miss and why did we miss it? And I was thinking a lot about this. So first thing I want to take note of is where do we have our deepest pressure? So we had our lowest pressure in through here. And as a result, as we were just paying attention to the way these fronts were slicing through, coming around these lows, I was watching how much air was being pulled from the center part of Australia into the east. And what we were noticing here was that the composite wind compared to average was much stronger than average, kind of straight out of the west going toward the east. And what it was doing during that time frame was a lot of moist air was here getting pulled into the interior, but then it was kind of being rained out into this area, leaving us with drier air that kept pushing farther to the east. So this is an area where if you look, the values are negative, and this represents much drier air than anticipated. And I don't think that we captured how dry this was going to be. So this was the stronger interior winds blowing across, and we can blame it on a lot of things, but I don't think I gave enough credit to what was going on with our negative, what we call AAO, Antarctic Oscillation, or you call the Southern Annular Mode. And what you can see here is really since September and then continue through October and the beginning of November, we have had a below normal Southern Annular Mode. It's negative. And as you look out here as to what that means as we approach summer, the negative phase tends to increase dry airflow from the interior. Now, I figured since we're kind of in a bit of a seasonal transition, we had seen models perform pretty well. I was going to stick with them in what they were saying, but I think it kind of came back to bite me here because the reality was we've landed like this so far this month. And now we're going to be looking forward into this forecast, trying to figure out where we think this pattern is going to go, and if the Southern Annular Mode, which as you can see here is expected to continue to stay negative, is going to give us that same outlook. Now, look what the models have done again. All right, here's the 10-day precipitation forecast compared to average from the newest European model run. And it's now got this region wetter. It's drier to the south in New South Wales. It's a little wetter along the coast here, wetter deep into the interior, and kind of a mixed in parts of Western Australia. And so we want to do a little model comparison, so I went out and grabbed the GFS. This is just another model, and it's kind of got the same pattern, this drier patch in through here, wetter in the interior. There's this region in through here that's shown a little bit wetter. We're just trying to make some assessments as to why it looks like this and to see if we can put some numbers to this as to what we expect precip to do. So we're going to do that here at the beginning. I'm then going to make a transition to give you both analog support and then long-range weather forecast model support for what I think, what's left of spring, how in summer, and what I think possibly autumn may look like based upon some key things that are transitioning. And honestly, some of that signal is right here. That's going to be an important factor in the near term. So let's get in and talk about it. This is a map showing surface dew point. Dew point is a measurement of the absolute amount of water in the atmosphere. The higher the dew point, the more moisture there is. So we've got some dry air in place right now. I'm recording this very early here in the morning. And what we're keeping an eye on, well, my morning, your night. But what we're keeping an eye on as we go through Wednesday and into Thursday is where this dry air is going. And are we gonna replace it with anything? These are the dry interior sections that tend to blow to the east, giving us the risk of staying drier. So as we play it forward, what I notice is this. By Thursday, getting into Friday and Saturday, some much more humid air begins to push its way in from the north. Can you see it here? So we're going to be replacing some of the drier air in this corridor with much more humid air, and it's going to move in this direction. Farther to the south, we still have drier air into the interior, and it's going to be moving in this direction. So the net effect of this is that, see that move? Look right there. See it? We're bringing in moisture here late in the week toward the weekend and not so much here. Now, that's not to not pay attention to Western Australia. You can see how dry the air is there as well as we work our way into this weekend. But what I'm most interested in is how this moisture is getting pushed, or the lack of it here, while setting up a frontal boundary right into that area on which to the north of it we're going to have better chances of getting some moisture in place. And I've already worked you all the way out through Sunday. Let's keep playing this out into Monday and Tuesday. Did you see how that all pushed north? That's that frontal boundary working its way north into the humid air, which means it's going to squeeze out the moisture that's there, replace it with drier air soon. So if I lost you there, the net effect of all of it is this. Let's watch the precipitation intensity and type forecast going forward. As we play this out, here we are through Wednesday into Thursday, we're going to keep an eye on some moisture moving through South Australia. But as we get out here farther, watch, you're going to note that our best chances Friday, Saturday, and Sunday, see where the best chances for the moisture is this weekend? It's pretty far to the north and then our coastal storms here. And that's where that drier air is trying to rob the ability to get moisture into this area and therefore precipitation. And so we get out there to Sunday and eventually into Monday, and the area front clears, possibly some more showers here across South Australia getting into Victoria. But we're going to leave a pretty large hole in this pattern where we're not expecting to pick up much precipitation at all over the next 7 to 10 days. Notice into week 2, it all clears out. Drier air comes back. There's some interior showers here that come in next Tuesday into Western Australia. But that's about it. And I want to tell you why to the north things that are changing there are so critical to your upcoming forecast. So let's get back into some precipitation anomaly maps. You got this one for the next 5 days. There's 7 days, so we are anticipating that. Day 4 through 10, that's when most of this is coming through, right? And that's when we see this larger dry section here, while better rainfall chances try to work their way into Western Australia. But that seems to be the mainstay of how this is all going to shake down. If we just look at the total precipitation out of this, we'll just add this up. Again, this is the European model solution. This is what we're getting. So if the front establishes itself and if the moisture is in place, the chances in through this quarter of picking up 25 to 50 mils of rain, it's there. We can see it. But it's that hole that's got me concerned. Around the periphery, there are rains, but into the interior, we're blowing too much dry air into this region. That was something I missed in the last forecast, so I wanted to kind of share that with you overall. Take a note in Western Australia as well. There's a larger region that's drier here, and to be honest, around Perth, we're not looking at much precipitation either. So that's just a quick look at these next 8 or 9 days, according to the European model, and assessing where the moisture is and how it's going to be moving around. Now, by every model that I've got, week 2 is showing up drier for a larger area here, except for some coastal storms, on this side of the higher elevation. All right. We do see chances for being wetter than average as a trough tries to sneak through here next week. This is way out there, November 19th to the 25th, bringing in better chances of rain into parts of Western Australia. But during that time frame, I'm going to be focusing on a lot of other things taking shape farther to the north that I think are going to be critical for your end of November, December, January, February forecast. And we're going to come back to that in a few moments here. All right, I do want to talk temperatures really quickly. Look at the temperature contrast we're expecting here. Now, this is a 1-day sliding window through the next 15 days of temperature anomalies. Okay, so you're kind of just watching the temperature pattern evolve. So we're much cooler than average across a large section today of Australia, while we're warmer here in Western Australia. And we watch as we go through Thursday into Friday. Look, we will open up an interior kind of warm swath. This is where that frontal boundary is eventually going to sit. Okay, watch it move back. Ready? This is now Saturday, Sunday. Do you see it get replaced? See the warmth here? Front comes through, kicks it north. See that? And that's what's going to initiate our rainfall chances. Now, where we're drier, we tend to maintain the warmer conditions longer into the weekend. I'm talking about New South Wales, while much of the interior is under cloud cover and rainfall, and that's why we see things much cooler. Getting out there to Monday into Tuesday and Wednesday, the front continues to push north, driving the temperatures down 5, 6, 7 degrees compared to what they should normally be for this time of year. And Western Australia starts to warm up a bit. But that'll cool back off once the next system starts to work its way in there, late in that week 2 time frame. That's when we see this starting to moisten up a bit, while much broader, warmer conditions begin to work their way back across much of Australia. All right. So all of that being said, we see the pattern as being dominated by really just one big front over the next 7 or 8 days. And we've kind of hammered that. Where do we go after that? And I'm going to show you the newest forecast. Now, if you go back through the last few months, what were we seeing all of the models predict for spring and summer? Wet, wet, wet. Everything was just wet. Do you remember that? And now we look at it, and I was saying, be cautious with this. We just have to remember that the models are going to overdo what La Nina's influence can be. They tend to do that in these certain circumstances where the La Nina is weaker. And now we get out here and see that the forecast from November 18th to December 18th is starting to show some drier signals. And this, I think, is well anticipated here, but could we go back over drier there? Are we continue to be drier in the interior? And what about South Australia and Western Australia and Tasmania as well? So what's happening here? Why are we seeing this? Well, the answer actually lies in what you've got there and the dryness we begin to see here. And I want to take just a moment to explain to you what is happening. This is kind of a neat thing, okay? I took a sea surface temperature map and I analyzed it. And what we have here is we have two competing winds in the tropics, okay? We have our stronger easterly wind bursts. So they're coming out of the east. That is what we call La Nina. That's all La Ninas are, stronger trade winds, and they're racing in this direction. But right now, and we've seen this for the last several weeks, our Indian Ocean dipole, which is why there is colder water here and warmer water there, has given us a stronger westerly wind burst. And they have been wanting to just live and meet in this area for some time. And that's important because that is tending to be where we're getting the momentum and the moisture and the heat out of the tropics into much of Australia. And that's been interacting with where the jet stream's been, the negative phase of the southern annular mode. We'll just kind of stitch all this together. Now, if these two winds, as they compete, maintain their strength, we're going to live in phases 6 and 7 in the MJO. And phases 6 and 7 are not bad phases for Australia. But there's something shifting right now. And we're about to see the La Nina win as the Indian Ocean dipole fades. And when it fades fast, I think it's already fading. The index was at negative 1.94 just a couple of days ago. Now it's down to negative 1.57. And if it goes positive, then we're in trouble. Well, we're not in trouble. We're just in an entirely different regime. So this is right now fading pretty rapidly. And when this gives up, now watch what's going to happen. When that gives up, these trades burst all the way through and reset the MJO back over to phase 1. And then La Nina begins to fade. So right now they're competing, they're strong, and they're both about to give up, in my opinion, in my colleagues' opinion. You know what it looks like? It doesn't look like much. You're like, really? This is all it is? It's these two regimes. Do you see the winds here going this direction? In fact, they extend all the way over to there. That's our La Nina. And these are the westerly wind bursts I'm talking about. And you're going, look how much stronger the flow is here and here. Yes, you are 100% right. But this is over a much, much bigger area. And the amount of moisture getting tossed around here, well, it's enormous compared to all this. But we always expect the stronger winds to be farther to the south. That's where the greatest temperature contrast is. But the birthplace, the exhaustion point of where weather comes from is here. It's along the equator. So these are the competing factors, and this is what I want you to see. Take a look at what's going on with our ENSO index, okay? We've just been steadily since August watching this drop, and it's probably going to peak in early December. When it peaks, watch the Indian Ocean dipole just fade and go to nothing. It'll just rapidly go away. It's already beginning. Do you see this? Watch. We've been building it since spring into June, or excuse me, since last autumn, through your winter, and now into spring, and it's just, boom, pop back up like that. And as we analyze this, and there's consensus across the meteorological community, that when it makes a break, we're going to just start to see something different, and we're already getting a hint of that. Now, the MJO is ultimately the thing that responds to the competition between, well, La Nina and the Indian Ocean dipole. And remember, it goes through 8 phases. 1, 2, you can keep filling the numbers, 7 and 8. Got it? See? Now, if we hold it hostage and leave it in one spot, we're pretty good at predicting weather. So in other words, you know what I want? I don't want either of these things to happen. I want it to just live in phase 6, 7 for a while. Because then I could more confidently tell you what's going to happen in the forecast. But this is what we think might happen. If the Indian Ocean dipole collapses, all right, the MJO is going to leave phase 6 and 7. See where it says initial? That's where it is right now. And it'll go rapidly through phase 8, 1 and sweep right back around to the maritime continent. It'll take about, I don't know, it'll probably take 25, 30 days to do that. But watch what this means. If it does that, we can now use these averages. And the moment it collapses, do you see this region going over drier? That's phase 1. Phase 5 and phase 6 tend to give us better moisture and drier into the 5, 6, and 7 tend to be drier in Western Australia. But this seems to be what the models are attempting to predict as they look out there and say what might happen at the end of November through December. The MJO will go quickly over here and then a massive reset back over to phase 1. And that is just the wrong phases. It's moving away from phase 6 and 7, and that's what tends to give us these drier looks. Now, that's what we think might happen. That gives us this outlook for drier conditions during that time frame. Again, November 18 to December 18th. And I want to just stress here, I said drier, not dry. So we're just paying attention to anomalous behavior in the atmosphere. That's our goal, comparing it to historical averages. Okay, what's going on with this La Nina? Well, I want to show you something. We are expecting a fast collapse in December and early January. And some of the forecast models by autumn are trying to bring the sea surface temperatures back into El Nino territory. Now, this is a very fast collapse. And it was interesting. My son just left for school. He says, doesn't that kind of look like the Titanic sinking? Like these are the two big smokestacks on it and the ship is sinking. Yeah, well, El Nino is sinking. I don't think it's going to last for very long. Forgive me, La Nina is sinking. I think El Nino is coming back. And to show you this, I've shown you this in the past. We've got historical precedent for this. If you look, all of the years where you were down here and boom, shot up like 1972 or 1982 or 1997 or 2002 or 2009 or 2023, those are all years where we came out of either a La Nina or a multi-year La Nina and found our way back into El Nino conditions. So before I show you any model forecasts, I would like to show you some historical precedents here. So I grabbed all of the years that went from La Nina to El Nino at the same time frame that this is expected to happen. And what we got was this. Now, just take a look at what these maps are showing. If you need to pause the video, do that. We found that in November, well, where did the MJO want to live? Right there. These are precipitation anomalies. This means wetter, and this means drier, okay? Now, what did we see? Drier interior. And we're kind of getting that, right? We're seeing that dry interior part right there. So that makes some sense. Well, okay, November, what happened in December? Well, in December, we kind of had a bit of a mixed bag. There was drier here, maybe wetter along the coasts, drier in Western Australia. That looks kind of similar to the current European model forecast. Something else to take note of. Argentina into southern Brazil, very dry. This could have a huge impact on the crops grown here. Now, this is winter for us in the northern hemisphere, but it's wetter in the wheat belt. It is wetter in the northwest United States. You don't compete with a lot of crops here, but there's some. But it's drier in our interior wheat belt and part of our cotton belt, and also in our southwest. It's also drier in this part of China where we have the Yangtze River. All of these factors need to be monitored very carefully. And I'm going to come back to a December forecast before I wrap this all up. What about January to March? Well, in January to March, the MJO becomes a bit more messy. And what you notice is we do see these drier regions beginning to show up. But it's not overly dry, but there's drier regions that begin to show up January to March. And then you say, well, what about March to May? Well, we tend to be a bit drier here and drier there and wetter to the north. You see, these transitions to El Nino have consequences. And if we look out there even farther, May to July, we tend to get ourselves into a winter time frame where we're drier across much of the east. And we're concerned about this other places too. Look, India's monsoon tends to be weak. We tend to be drier in summer over where we grow. This is our Russian wheat belt. This is Ukraine, corn, soybeans. Take a look at the corn and soybean belt for the United States. We tend to be a bit drier too. Now, that's history. That is entirely based off of collapsing La Ninas. What are the models saying? Well, first of all, are the models at least predicting the La Nina to collapse? Let's go look at it. Here we go. There's the La Nina. There's the negative Indo-Ocean dipole. So again, that's cold here, warm there. Now that was valid in November. By December, look, we've lost the IOD. The La Nina is peaking. January begins to fade. February nearly gone. By March and April, we start to see the warm water sloshing back. And that's going to be an entirely different regime by May. So the net effect of this, if we come into Australia, is to let's just look at our precipitation patterns and just take it kind of in a 3-month swath. That's November, December, January. Okay, now I'm starting to see why we're getting a few of these features showing up. Could be wetter to the south and wetter along the coast? Yes. You notice that there's no strong anomalous precipitation being forecast for Western Australia during that time frame. What about December, January, February? Now look, the model is doing the typical La Nina winter thing. It's like, make it wetter here and drier there. But what we saw a moment ago was that December, January, February, and that January, February, March doesn't often have wetter east and drier west. You want to go back and look at it real quick? There it is, January to March. You see, it tends to suggest some drier risks here. So I can't ignore that when I look at these long-range forecasts and just want to blankly tell you, yep, you're going to be fine. I don't think that's the case. I don't mean to be a pessimist. In fact, I'm not. I am an eternal optimist. I'm not just a glass half full. I'm like, put one drop in. I'm like, yeah, that glass is half full. I'm always optimistic about the weather. If you don't have hope, what do you have, right? But I mean, the thing here is I want to note where the models are different from history, because they are not calling for risk in this area for summer, getting even over toward autumn. They're putting all the risk in the drier conditions here. So we have something to watch going forward in this forecast. And by the way, other global models are looking very same. And when we talk again in a couple of weeks, I'll show you the full spread of them as we finish out this month. So, long story short, I think we need to be very cautious of the speed at which La Nina fades. And the first thing that will break will be the Indian Ocean dipole. And if I've completely lost you, and that's okay, I apologize for that. But I want you to understand how complex of a forecast this is going forward, knowing that we are concerned about, hey, we've had 5 La Ninas in 6 years. Are we going to make the transition? And I'm starting to see some signals that could be the case. Now, to wrap this all up, I'd like to give you a bit of a global outlook over that same time period, November 18 to December 18. So we've studied and understood this. So watch, MJO squeaks through and resets. We know that's going to happen. Take a look at what happens across the Russian wheat belt, Ukraine, wetter conditions. That's going to be critical for that crop, but very dry into the interior of China. That makes exact sense. We saw that in the historical analogs. Throughout much of the United States, a very active pattern coming through. We're expecting, I've already had some snows in my backyard here. You should come visit. We're covered in snow right now, and I live in Illinois. We're expecting a pretty volatile run of temperatures, and it's going to be critical to see if this moisture comes through for some of our winter crops as well and our western U.S. mountain snowpack. But down to South America, models are predicting better rains coming through Brazil. They are not on target for planting. They're behind pace on planting. They're off by about 8% compared to last year. The bigger concern is what happens in southern Brazil and Argentina going forward. These are areas that, because of the way the La Nina is shaping up, that we have to be concerned about them developing drought going forward, which could have a huge impact on crop production out of that area. So there is plenty to be watching here globally. And I'm just going to ask you to just stick with it. In the meantime, okay, if you need maps, if you need to keep track of it, go to this website, ag-wx.com. That's my website. I'm still piecing together better tools for you, but come over here to Weather Models, right up here. And then you can click on European Model, Artificial Intelligence, any of these, okay, except the top row. The top row is all United States models. Don't look at those. But go to the European Model, click on Australia, and now you can watch this every day. These maps update automatically. Pick any weather variable you want. You've got it. I'm about to do a massive expansion on this. Just to nerd out with you for a second, I have reworked some of my code and refactored it such that now we're going to be able to produce somewhere north of 250,000 different weather forecast maps from multiple models on a much slicker interface. And I'm creating your state by state, region by region, territory by territory maps. I'm super pumped about it. I'm going to be sitting on an airplane for the next 7 hours today. Hopefully I get to fly to where I need to be. Got to give a big talk tomorrow in Oregon. And if I'm just sitting there, I'm coding. So we'll work and we'll get this going for you, okay? Okay, sorry, that was a lot of extra content today. We'll talk again in a couple of weeks. Be safe. Thanks.